Hey everybody, so today I'm going to talk about electrons in the Bohr model, and this will be really helpful for you on your project because you're going to have to actually draw a Bohr model of the element that you have, and then you're going to have to click and drag the electrons into the different energy levels. So the first thing that I want to talk about is Niels Bohr and this planetary model. So this guy named Niels Bohr, we talked about him when we talked about the atom, and he says that the nucleus is positively charged in the center of the atom due to the protons. Remember, inside the nucleus of the atom there are protons and neutrons, but the neutrons have no charge, or a charge of 0, and the protons have a positive charge. So since the protons have a positive charge and the electron has a negative charge, the electron is going to orbit the nucleus. And he said, okay, well, how do the electrons orbit the nucleus? Is it in a random pattern? Is it a zigzag? What kind of pattern does it orbit the nucleus in? And the reason that it orbits the nucleus is because of those charges. It's negatively charged, the electron, and the proton is positively charged, so therefore it's attracted to the center. Remember, opposites attract. So he theorized, Niels Bohr did, that the electron is actually going to orbit the nucleus, kind of like the planets do around the sun in these circular or elliptical orbits. And an elliptical orbit is just like it's like a circle, but it's not a perfect circle. It's kind of like elongated, like it's stretched out kind of. All right, he also said that the lowest energy level, so the electrons that are closest to the nucleus, they have the least amount of energy. And the reason they have the least amount of energy is because the positive charge at the center of the nucleus and with the protons, it's holding on really, really tightly to those electrons. And it also says that as you get further and further away from the nucleus, then the amount of energy is going to go up. So let's look at what this would look like, a picture here. So this is the Bohr model of the atom, and he says that the nucleus is right here, and the nucleus is positively charged. And then we've got each one of these circles that go out from it, and these circles represent the energy levels. So this energy level here, they call it n equals 1. This is the first energy level. It is the lowest amount of energy, and the reason it's the lowest amount of energy is because it is so close to the nucleus, and this positive charge in the nucleus is holding on really, really tightly to these negatively charged electrons. And as you get further and further away from the nucleus, the amount of energy actually goes up, or it increases, because it's really hard for the nucleus's positive charge to hold on to these electrons that are orbiting in this circle out here. And it's even more difficult for the electrons, or for the nucleus, to pull in those electrons that are out here in this third circle. So what happens whenever you apply some sort of energy, like you add in extra energy to the electron? And that's what I want to talk about next, and that's what this picture is kind of showing you here. So on Friday, you did the flame test lab, the virtual one, and I know it was frustrating, I'm sorry. The electrons that are in the atoms, they are in what they would call the ground state. And the ground state is just the normal amount of energy that those electrons have, depending on how far away they are from the nucleus. So remember, the closer you are to the nucleus, the less energy you'll have, because the positive charge of the protons are just holding you really tightly. So the electrons have a ground state, and that's the lowest energy state that an electron just normally occupies. But then whenever you add some sort of energy into the electron, so for example, if you add heat to it, maybe in the form of a flame, then those electrons are going to move from their ground state to their excited state. So they picked up some energy, and now they're all pepped up, they're all excited. But sadly, those electrons can't stay in the excited state for forever, because, eventually they lose energy, kind of like you do. You're all hyped up, and as the day goes on, you get tired, and then your energy level kind of goes down. So the electron, whenever it goes from the excited state and it falls back into its ground state, it releases some energy. And it emits this energy as a piece of electromagnetic radiation. So remember, we talked about the electromagnetic spectrum last week. We talked about, X-rays, gamma rays, ultraviolet, visible light, all of those. And when we did the flame test, the energy or electromagnetic spectrum that it released was visible light, and it was in a certain wavelength of visible light. That's why we saw the different colors, which is actually pretty cool. So I'm going to show you this picture here, So let's say that this is the ground state here, where the electron just normally is in its normal energy level, and it's just circling the nucleus, circling the nucleus. Whenever it absorbs some sort of energy, maybe from electricity or maybe from, like a flame in the form of heat, it's going to jump up to one of these excited states. And these excited states here are showing you the various colors. So let's say that this is an electron that's in the ground state for like copper. When we add the heat energy into it, it jumps up into this excited state here, and since the flame was kind of a bluish color, a bluish-green color like a teal, it would probably be somewhere within this blue line and this green line. So it moves from the ground state to the excited state, but then it can't stay there for forever, because remember, it's going to lose energy. And this energy, as it falls back to the ground state, this energy is released, and it's in the form of visible light. And that's why we see those different colors. This next one here is also showing you the ground state versus the excited state. So the ground state's the normal state that it's normally at, known to have zero energy, has a high energy compared to this excited state over here. This one is highly unstable, and when I say unstable, I mean that it can't stay there for forever. It has to fall back to its ground state. The least possible distance is the distance from the ground state to the atomic nucleus, and then electrons that have higher energy are located in, further away from the nucleus. All right, so the next thing I want to do is I want to talk about the electron diagram for the Bohr model. So Niels Bohr, like this picture here shows you, he organized them into these circles, and the circles are showing you how far away the electron is orbiting from the nucleus. So each one of these rings or these circles can only hold a set amount of electrons. There's just not enough space for these electrons due to the distance between the nucleus and that ring that it's orbiting in. So the one that is closest to the nucleus, it can only hold 2 electrons. And those 2 electrons are usually placed opposite each other on the ring. The next energy level, the second energy level, or the second ring, it can actually hold 8 electrons. And usually how you do this is you put 1, 2, 3, 4, and then you go back and pair them together. And I'll show you how to do that in a second. The next energy level, or the third circle, can hold 18, and then the fourth energy level can hold 32. There are some elements that have more electrons than this, but we'll talk about that later. All right, so here is an example of a Bohr model. So it says draw the Bohr model for fluorine, or F. So the first thing you want to do is you want to determine the total number of electrons by looking at the atomic number or the periodic table. So the atomic number and the number of electrons are going to be the same thing this time, and it's not going to change in this unit. So again, the first ring or the first circle can hold 2 electrons, the second one can hold 8, and then the next one can hold 18. So I've kind of made this picture here. It says draw the Bohr model for fluorine, or F. It says how many electrons does fluorine have? And it's wanting the total electrons, not the valence electrons. So if you open up a new tab and you type in atomic number of fluorine, it's going to tell you 9. So it has 9 electrons. All right, so it looks like I've given you too many here. So let's take this first one and let's move it into this first energy level here. So this is the first energy level. All right, and this one can hold how many electrons? It can hold 2. All right, so we're going to move them here. All right, it says how many electrons can this energy level hold? This circle hold, type here, 2. All right, the next one, it says how many electrons can this energy level hold? It can hold up to 8, but we've already given out 2, and 9 is the total number of electrons. So the total number of electrons is going to be 9, and we already used 2 of them in the first energy level, so now we've got 7 left over. So what we're going to do is we're going to drag 1 here, 1 to this side, 1 to this side, and then 1 to this side. All right, then we're going to go back and pair the ones that are together. So we've got those, and those. All right, so now I've given out all the electrons, right? I've given out 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so that's 9 electrons, and all of these are just left over, so you can just delete these, okay? And now it says how many electrons can this energy level hold? It can hold up to 8, but we didn't have enough to give out. We didn't have 8 to give out. How many electrons can this third circle hold? That's going to be 18, but we really didn't need to use that. Alright, so I hope that you enjoyed this video. I tried to keep it short and sweet. I hope you have a great day, and if you have any questions, send me an email. Have a great day.